This is the Building Automation Monthly Podcast with Phil Zito, episode 139. Hey folks, Phil Zito here, and welcome to episode 139 of the Building Automation Monthly Podcast. In this episode, we are going to be talking through 3 steps for designing an IP network. Now, this episode is going to be very similar to a talk I gave recently at the Honeywell Momentum Conference 2018. And after going through this conference, after talking with a lot of folks, I realized that we still have quite a ways to go as far as IT education goes for building automation professionals. And this episode is going to bounce all over the place. It's going to cover a lot of different things, but by the time you finish it, you'll have a pretty good understanding of where you stand when it comes to IP networking, and you'll have a pretty good idea of what you need to do in order to go and design an IP network. So what are the 3 steps to designing an IP network? Whenever it comes to things related to IT, I find that a lot of folks actually would do best by focusing less on the technical and focusing more on the process. Now, this may seem a little foreign to those of us, especially those of us who are very technically oriented, but for those of you who are in sales, who are in engineering, those of you who are owner-operators, this is going to be good news, because while there is some technical aspects definitely to creating an IP network, there's a lot of stuff that you can get done, and there's a lot of information you can apply that is non-technical in nature. So I'm speaking mainly now in these next couple minutes to those of you who are non-technical, because I find that a lot of non-technical folks avoid technology. We will definitely get into the technical aspects later in this episode, but there's a lot of folks out there who need to understand how IP technology works, and they avoid it simply due to the fact that it feels technical to them. So if that's you, then these first couple minutes are going to be extremely beneficial to you. And I would say the rest of the episode is going to be very beneficial to you as well. So what is IP technologies? That's kind of one of the biggest things that folks get hung up on, is you hear the term IP, and a lot of folks naturally associate that with Cat5 Ethernet cable or Cat6 Ethernet cable, and it could not be any further from the truth. IP, quite frankly, is a logical construct. Now, what do I mean by logical construct? IP is something that doesn't actually exist. There is no IP network. There are Ethernet cables, there are wireless access points, there are cellular towers, there's point-to-point microwave, all of which could communicate technology, or could communicate data rather, utilizing IP. However, that doesn't mean that they are IP. So when you hear IP controls, or when you hear an IP network, your mind is naturally going to go towards thinking of switches, thinking of routers, thinking of Cat5, Cat6 cable, thinking of IP addresses. Out of all of that, the only thing that is true in your thoughts is IP addresses. Because here's the deal. All of what I just described to you is dependent on using a physical local area network, switch and router topology, meaning that's how you structure the network. Now, why does this matter to you as an engineer? Why does this matter to you as a sales professional? Because when you're talking to customers and their IT group is getting all up in arms about IP controls, usually what they're getting up in arms about is the actual physical network. Maybe they have to provide more switches and switch ports. Maybe they have to go and they have to share their VLANs, all sorts of things, but none of that is quote-unquote IP. That is all physical network. Are you following me with this? I mean, is this making sense? This is really important, but it's something a lot of folks don't talk about. See, you get all these manufacturers out there right now who are releasing IP controls, and what they're actually releasing in most cases is wired Ethernet controls. So controls that are using either wired Ethernet, or they are using some form of ring protocol using Cat5, Cat6 cable. And it's important for you to understand this because that's not necessarily IP. You could have a product line that has wireless. You could have a product line that uses cellular. A lot of smart equipment uses cellular. And technically, it is using IP. But at the same time, it's not these Ethernet switch-dependent controls. So as a salesperson, as a consulting engineer, as an owner, when you're talking to folks and you're wanting to think through what you could potentially utilize for your controllers, for your smart equipment, for your supervisory devices, realize that IP is not necessarily wired Cat6, Cat5 cable. And if you don't know what wired Cat6, Cat5 cable, it's basically that cable that comes out of your cable modem and goes to one of your devices if you were to hook it up. All right, with that being said now, let's dive into going the 3 steps for designing IP networks. All right, so step 1 is quite simply, we're going to go and define our role in the design. So we want to find out what our role and responsibility is. We want to understand if we are the IT group or if we're not the IT group. This is really important because if you are expected by the customer to be doing all of the design, if you're responsible for supporting the IT network, if you're responsible for being the person who's ensuring that their network is secure, these are all problems that could really affect your ability to execute an IP controls installation. Now, on the same token, if a customer has a very savvy IT group, for example, is doing some consulting with a government organization today, and they have very strict IT requirements, because that the ability to influence the design and the responsibility in the design of any networked device is going to be significantly different than if we're working with a commercial real estate building that had no IT group. Understanding this up front is going to affect how you sell controls. It's going to affect how you engineer controls, how you specify controls, really being cognizant of your customer's IT maturity and understanding where they stand as far as having an internal IT group or not is going to dramatically affect how you execute an IP controls design. Now, why does that matter? That matters because you could be either under or overestimating hours. You could be creating or not addressing problems. You could be going and setting yourself up for failure by not understanding the customer's reluctance to a certain technology, only to find out after the job gets awarded to someone else that you were disqualified because you didn't have a technology that that IT group felt comfortable with. I've seen this time and time again happening all over the place. And it's only going to get worse as more folks are trying to push different solutions and not having the IT maturity to address the concerns that customers have related to those solutions. So for example, if you were to go and suggest to a very secure-minded, thoughtful IT group, which is maybe in the DoD space here in the United States, so Department of Defense, and you were to go and tell them, hey, we're going to put this controller on your IT network, that would probably not, I know that wouldn't go well. And they have a very long process of evaluating solutions that are able to be on their network. Now, if you were to take that same approach and go to a commercial office building, you would most likely get a very different response, if any response at all, because they probably don't have an IT group. However, with that being said, now that that customer doesn't have an IT group, guess whose responsibility it is to work out all of the aspects related to that network, to think through all of the network design, all of the network access, all of the network support. And I'm telling you, for a lot of you, this is a untapped gold mine that you're able to get with customers in the mid to light commercial space that maybe don't have their own IT groups, that you could potentially support with an IP control solution, and then you could support their network as a value-added high margin service. That is something that is being untapped by so many folks. So back to the point of this episode. Step 1, find out what your role is in the design. Step 2 is then to define the design requirements, okay? So this is where you need to start to figure out what are the requirements of this design. And this is something that I've seen time and time again. How many of you all, I realize you can't answer me here, so I don't know why I'm asking that question, but you can in the comments actually. But, just think, have you ever went and did a wireless controls project within the past 10 years? I'm not talking recent wireless solutions. I'm talking, like 4 years ago when folks were still kind of figuring out the wireless space. I would argue they still are figuring out the wireless space. But did you do a wireless job and it just didn't go well? Controllers didn't communicate properly. Things just weren't working. You ever experienced that? If you did, it's most likely because the design requirements associated with that wireless control system were not implemented. And remember that IP can be over wireless. It can be IP over Zigbee. You can have IP over 802.11. You can have IP over 4G or 3G. That's cellular, by the way. Now, the thing is that IP, like I said, is just a logical protocol. But these physical standards that you're using, whether it's a mesh network, a wireless network, a cellular network, a wired network, they all have design requirements. And a lot of folks don't think through the design requirement impact when they are going and implementing an IP control solution or an IT network for their building automation system. This doesn't necessarily have to be IP controls. This could simply be IP metering. This could be IP integrations between some backnet IP systems. There's a variety of different ways you can use IP. The thing is, though, is you've got to think through the requirements associated with anything you're doing. Now, how do you do that? Well, I like to do it using the OSI model. Now, the OSI model, or the Open Source Interconnection 7-layer model, is a way of basically laying out network communications and application communication. So basically everything from the physical connection all the way up to the application service. And I really like this model because as you go through the steps here, it really enables you to see where there may be any potential gaps in your design. It enables you to ask questions. Now, this is going to get a little techie. This is going to get a little nerdy for a second, but it's something that honestly, if you all don't know the OSI 7-layer model and what I'm about to tell you is confusing to you and you're a technical person, then I got some bad news for you. You are really going to be up a creek without a paddle in the next couple years because this is where everything's going. And if you don't understand, at least the first 4 layers of the OSI model, then you're in for a world of hurt. I'm telling you, just heed my words. Do whatever you have to do to get trained up on this. We offer a training program. And there's many other places you can go to get trained on IT. It's something you really need to take seriously. All right, with that public service announcement done, let's go back. So as I mentioned, there's 7 parts to this OSI model. And there's 4 of your I initially will focus on any network design I'm doing, whether it's wireless, wired, or something in between. So the first layer 1 is called the physical layer. This is where your actual physical medium is. So this could be wired, this could be wireless, this could be point-to-point microwave, but this is basically, it outlines kind of what you're going to use. The big focus area here is finding out if you're doing a wired or a wireless network. You need to figure this out now. Don't figure it out when you're going to show up on the site. Don't find out that the customer is not going to let you have a Wi-Fi access point to yourself, or that they're not going to let you share a Wi-Fi access point, or that you're not going to be able to have your own SSID sharing across an access point, that you're going to have to have your own wireless LAN controller. I mean, all this jazz, you need to figure that stuff out prior to going and actually executing a project. I know that seems pretty straightforward, pretty basic, but it's really important. So you figure out, what are you going to be doing physically, network-wise. Then you move on to what is called the data link layer. This is layer 2, and this is going to be where you're focusing in on that local area network. This is the layer in which MAC addresses exist. So you've heard of MAC addresses, you've heard of Ethernet, you've heard of MSTP. Those are all data link layer protocols and concepts. And this is something that becomes really important for you to understand. Understanding how you're going to do port security, understanding how the access points are going to be set up if you're doing wireless. How are you going to go and set up your switches if you're using switches? If you're using a ring architecture, how are you going to do that? All of this stuff is very important. So we focused on our physical layer, and then we focus on our data link layer. And it's from there that we move into the network layer, which is layer 3. Now, this is where we start to get into the logical aspects of IP. Now, this is independent of whether you're wireless, wired, etc. This is where we start to focus in on things like IP addressing. Are we using static or dynamic IP addressing? Routes and quality of service and domains and default gateways and subnet counts. If this feels at all foreign to you, look back at our previous episodes on IT networking. Also go and check out our IT for BAS professionals online course. Because if this stuff's foreign to you and you are in any form of technical role, then you are not prepared for your future career. That's just the reality. You may not want to hear that, but you're going to be in a world of suck in less than a year, I would guess, based on what I'm seeing happen in the market right now. With that being said, we move on from there to layer 4, which is our transport layer. Now, the transport layer is where all the ports exist. Now, ports are different than the physical ports that we talk about in the data link layer. This is logical ports. These are ports that exist for applications. So the important thing to understand here is this is where you run into issues where, your server doesn't communicate to your supervisory device because you don't have UDP port 47808 open, which that's the backnet port, by the way. And ports are especially important for you to understand because if you're working with any sort of secure network, this is where you have to get applications tested. You have to get your message traffic tested. You have to go and get a message profile. That way the application can access control lists, the ACLs, the intrusion prevention and intrusion detection systems can all be properly configured. Okay, so I just dumped a bunch of information into your lap. That was probably, for a lot of you, just drinking from a fire hose, and it just seemed Greek. What I want you all to take from that, and this will probably be one of the shorter episodes, and like I said, it's going to bounce around just a little bit because there's just so much here. I mean, each one of these topics could be an episode in itself. But what I want you to take out from this, right? If I was sitting in your shoes and I'm like, okay, I've listened to 18 minutes of this episode. What do I really need to know from this? What do I need to take? One is you really need to understand your role in the design. You really got to understand how to find who it is in an IT group that you need to work with, what level of security expectation they have, and what their tolerance is to different IP technologies, both wired and wireless. Once you understand this, then you need to go through and understand the design requirements. And that's step 2, right? Step 2 is understanding the design requirements. And then step 3 is actually going and designing the IP network. Now, that's a little harder to teach on a podcast because it's such a visual concept. But essentially what you need to do is you need to understand whether you're wired or wireless. Then you need to understand your IP addressing scheme, your routing scheme, and then you set up your subnets and your VLANs. and then you make sure that you have the proper access to the ports. I know I make that seem very easy, but I've done a lot of IP network designs for hospitals and airports and commercial real estate and higher ed, et cetera, et cetera. So to me, it's really easy. For a lot of you, it's going to be fairly difficult. The best way I've found to go and actually learn that is to go and just start building out what you think an IP network should be like for your projects, and then work with your customer's IT group and see what they come up with. And then understand the difference between the two, look at the difference between the two, and compare where you've ended up. Okay, like I said, this was a shorter episode, and it was definitely one of our more technical episodes. Probably a little uncomfortable for some of you who are less technical, but I want you all to listen to that. And for those of you who are less technical and are still listening, I applaud you for listening, because just hearing this dialogue, while it may not have made sense exactly to you, it's going to expose you to the terminology. So for those of you who are in sales or operations or in engineering listening and aren't necessarily designers and programmers, whenever you hear technical things like this, listen for context. Listen when the certain words are used. So for example, when I talk about ports, I talk about both software and physical ports, right? When I talk about the physical aspects of the network, I talk about whether it's wired or wireless. Now, this is important for you to be able to have that first conversation credibility. And this is something I want all of you to listen to. When you are first engaging with an IT group, it's extremely important that you use the right verbiage and that you have first conversation credibility. What is first conversation credibility? That is where, when you first talk to someone, you're speaking in their language. You're not misusing terms. You're not just basically going, give me access to the thingy I need to put 10 MS on. I mean, where you just sound, like some redneck out of middle of nowhere. And they're like, oh my gosh, I'm not going to let this guy or gal touch my network. You've got to go and make sure that you are going and sounding competent. No one expects the sales guy to be able to go and engineer a system. However, being able to go and speak the proper language is really important. So like I said, this episode was a lot of different things. It's got a lot packed into it. I debated whether I wanted to break this out into several episodes or whether I wanted to make this a single episode. And I went down the single episode path simply due to the fact that so much of what I'm teaching in this episode, to dive deeper, would be visual lessons, and it's something we cover in our IT course. So if you want to get further instruction on IT design, if you want to get further if you want to get further instruction, it can feel like destruction sometimes. But if you want to get further instruction on how to design IT networks, how to work with IP, how to work with networks, databases, servers, then you definitely need to check out our IT for BAS Professionals course. Now, everything I covered here will be available at buildingautomationmonthly.com/139. Once again, that's buildingautomationmonthly.com/139. Now, in next week's episode, I'm looking at it right here, we're actually going to be going through the 5 things I've learned building a BAS training business. So for those of you who are building your building automation businesses, for those of you who are building your building automation groups, or even for those of you who are building your careers in building automation, episode 140 is going to go through all of that. We've had a crazy wild year building Automation Monthly since last October 2017, when we decided to take it full time. I'm going to tell you kind of the things I've learned, the mistakes I've made, and the different kind of lessons that you can learn from, which is what I highly advise you do. Find people who are more advanced than you or where you want to be, and learn from their mistakes and figure out what you can do differently. All right, folks, with that being said, I'm going to conclude this episode. Thanks a ton for being here. I can't wait to talk to you all again next week. And until next time, continue to learn, continue to push yourself. None of these topics are beyond you. I don't have any special gift for me to have learned these things. It was just hard work and study. And if you apply yourself and if you listen to what I've told you to focus on in these episodes, you will be vastly further along than I ever was in my career. So I encourage you to continue to grow, and thanks a ton for listening. Talk to you all again next week. Take care.